Hi everyone. Today I'm going to talk about combination circuits, and combination circuit simply means a circuit with both series and parallel elements, right? So I'm going to just write that down. Combination basically means you have series components and you have parallel components, both. So if you take a look at example 1, you can see that there is a parallel. Right, these two are in parallel with each other. But here's the trick question. Someone could ask you, the 2 ohm resistor and the 3 ohm resistor, are they in series or parallel? The answer is, there's no answer. They're not in parallel with each other for sure. But are they in series? Then you would ask yourself, the current going through the 2 ohm, does it definitely all have to go through the 3 ohm? No, because the current actually splits here, right? The current actually splits here. So actually 2 ohm and 3 ohm, they're not related by series or parallel. They're not related in either of those. Yeah. And so what you can see though is that this resistor, 2 ohm, is in series with this entire chunk. Now if that's a bit confusing, don't worry. Let me just show you some of the working and how I can simplify the circuit, and I think it will make sense. So over here, let's say we want to, basically over here, ask you this question, what is the R effective? If I want to combine all the resistors, I want to find what is the total effective resistance. The first thing I want to do is actually, I first want to simplify the parallel side first. As you said, the 2 ohm and the 3 ohm resistor and 4 ohm, I can't just add up because they're not related by series. They're not. But these two I know are related by parallel for sure. So let me start with that. So let's call this part R parallel, which is basically the R effective from the parallel side. And we can solve that by using the formula 1 over R, in this case R parallel, equals to 1 over R1, which is 3, plus 1 over R2, which is 4. Right, so these two, 3, and this one, 4. And then the rest is algebra. So let's go ahead and do that. We get 1 over R parallel equals to 4 over 12 plus 3 over 12. And so 1 over R parallel gives me 7 over 12. And let's write down as, if I flip the fraction on both sides, I get this, and this simplifies to 1.7143 ohms, and this is just 5 SF, because I'm not done yet. So actually, if you take a look, this R parallel is equal to 1.7143 ohms. That means I can actually rewrite or redraw this circuit as like this. And there was 2 ohms. And the R parallel side, the 3 and 4 ohm resistors, actually can combine, to give me, okay, there's not enough space, but this is 1.7143 ohms. Yeah, isn't that cool? So basically, you've started to simplify the circuit. Can you see that? You started to simplify. From this, you combine these two resistors using the formula that you know to give a total resistance just for the parallel side, and then you redrew the circuit like this. Now this circuit looks a lot simpler, and what we can do here, we can see very clearly now that all the current going in through the 2 ohm resistor has to go in through this resistor. So these two resistors are definitely in series with each other. Then we can say our R effective, the total resistance of the whole circuit, is 2 plus 1.7143. I just brought this down. And that gives me 3.7143. And let's just put it to 3 SF. There you go. I'll zoom out. Let's take a look. All right, and so now let's look at another example, and then I think as you see more and more, it'll get clearer and clearer. In this case, we can see these two are in series with each other for sure, because the current that goes through the 1 ohm has to go through 2 ohm, and these two are in series with each other. But these two, how are they related? It's a bit more complicated, right? You can't just apply the formula. So here's what we do, and of course these two are even more complicated because they're all stuck within their own parallel and series parts. So here's what I recommend. Combine these two first using the series formula. So always start with what you definitely know. You know they're definitely in series with each other. It's not complicated. So let's start with this section, and let's call this R. Let's call this R series 1, and let's call this part R series 2. I'm just labeling them. So for R series 1, oops, 1 is simply 1 plus 2, which is 3 ohms. And then R series 2 is definitely 3 plus 1, which is 4 ohms. And ta-da, we just redrew this whole circuit as R series 1. So that is 3 ohms, 3 ohms, and then R series 2 is 4 ohms, and then we are left with the other one, which is 5 ohms, like this. So you can see how we've managed to simplify the circuit. And then from here, it's very similar to what we had just now. So we still can't simplify this with the rest, but we know that these two are definitely in parallel. So let's go ahead with that, right? These two are definitely in parallel with each other. And so let's call this R parallel. You can call it whatever you want as long as you are not confused when you're doing your working. Of course, don't call it R effective. R effective is saved for the final answer. And so what we can say right now is 1 over R parallel is equals to 1 over 3 plus 1 over 4. And I'll save the working. You can rewind and watch. It's actually exactly the same as the previous example for the parallel part. And so it will simplify to R parallel equals to 1.714 3 ohms. Yep. And so you can see that we further simplified the circuit to look like this, where it's like this, where this is 1.71043 ohms, and then we're left with this original one, which was 5 ohms. Am I right? Yep. And voila. So you're really simplifying the circuit step by step by step. So these two are in series with each other, which is very clear. So let's just finish the question by saying R effective, this is total resistance, is actually equals to 5 plus 1.7143. And that gives me 6.7143 ohms, which if I put it to 3 SF, that is 6.71 ohms. There you go. So actually you can see we actually simplified the circuit all the way to look like this. It's actually a quest to simplify the circuit. Yeah. So let me just zoom out all the way and you can take a look. And there you have it, combination circuits.